Hello, my name is Tomer Libal. I'm a researcher in the University of Luxembourg. I'm going to talk about trying to automate the GDPR compliance checking. So first of all, what do I mean by automating this, or what is this process? So GDPR compliance covers many different things, like actions. The controller needs to notify subject of data collection and processing, having different members on your team, like data protection officers in some cases, having different documents like privacy policies and cookie notices, and of course they need also to be compliant. Having specific code in place for encrypting the data, having different procedures for proper training of the team, etc. And this is just a small subset of the tasks that are encompassed in GDPR compliance. So clearly the process is complicated and also expensive. Fines are much more expensive. So in 2019, the GDPR fines amounted to about €500 million. So what is the automation of this process? What's the idea? First of all, we can think of several of the tasks that were just mentioned as ones that can be captured by documents. So for example, privacy policies, cookie notices, and data breach notices are already documents. And if they exist, they can be checked for compliance. Their existence itself and many other different things like notifying, getting consent, etc. can be captured by business processes. And one way of capturing these processes is by using diagrams. So we can have digital documents that capture different tasks required by GDPR compliance checking. And then we can ask, can we automate the compliance checking of those documents? So currently for free text documents like contracts and also privacy policies, there are some machine learning based approaches which facilitate compliance checking, but they of course do not perform the compliance checking itself, they just facilitate the work. We take another approach. We want to use automated reasoning, which is based on some knowledge, and this knowledge is formalized into formulae. Then we talk about we take a specific inference system, let's say propositional first order logic, and now software can be written which can check if a new formula is logically derivable from the knowledge. So this method is less popular than machine learning, mainly because the amount of work to formalize the knowledge, but it's used in more critical systems like hardware correctness, software correctness where there are real-time operating systems, and train scheduling, and also in mathematics where you need formal results. So the four colors theorem is a famous result proved by automated reasoning, together with help, of course, with humans. So what's the concept of the result that I'm going to talk about? We take privacy law and formalize it. This is our knowledge. Then we have various inference systems. There are several possibilities. Some are more expressive and can capture more subtleties of the law, and some are less expressive, but their advantage is that they are much better automated. So tools are much more efficient and faster, etc. The first can be noted by higher order logics, and the second, we use first order multimodal logic. Now that we have these two in place, we need to translate some compliance problem into a formula and execute an existing theorem prover. The theorem prover gives us either an explainable and detailed proof of compliance or a counter model for non-compliance. So this is the concept of the work. And now I'm going to show a demonstration of how it works in practice. There is a website with a user interface which allows the tool already to be used. The nai@uni.lu, and the demo account is gdpr@nai.lu, and the password is nai. So let's see the demo. So I put the email address I just mentioned and the password, and I submit. And I can see here an example of GDPR Article 13. This is read-only account. So I can open this just to see what does it mean to have the knowledge formalized. So here the whole article was being copy-pasted into the tool and was annotated in order to capture the legal meaning in the right context. Of course, you might have different contexts. There are several issues. It's also evolving. So this really needs to capture a specific context of the legal text. Once the text was annotated, it is turned into a formula, a different formulae. You can see here that they are not that trivial and they are mapped to the text in the legislation. One thing that we can already get for free is we can check different properties of our knowledge because it's now formalized. So for example, we can check if it's consistent and the Torah improver. Now we need to formulate a different formula to send to the Torah improver, but it still can tell us that it's consistent. Okay, so this is about the knowledge. We can also have a look on different compliance questions, compliance problems. So here we have several problems. The first one tries to see, it's within 24 hours, not days. It tries to see if we can put in our privacy policy, for example, a clause that we will update you about the purpose of the processing within 24 hours after the time of processing. We want to check if this sentence is compliant or not. As you can see, we had to formalize the problem itself, and the problem contains more than just this sentence. It also contains the existence of a controller, a processor, and the controller has nominated a professor to process the data once and then another time, because we are here dealing with not the first processing but further processings, which have further processings have different obligations according to the article. Anyway, there is some work required in order to formalize that, but once we have it formalized, we can click execute query. The tool tells us that it's counter satisfiable. There is a counter model which tells us that this sentence is not derivable from the legislation. And in general, a counter model can give us the information of why it was not derivable. This is an example of how the sentence is formalized after being annotated inside the tool. Let's have a look on the second compliance question. Here we ask if we are allowed to put in the privacy policy, we will update you about the purpose of the processing before the time of processing. This is a slight difference, and we can click execute query and we see that the query is valid. This sentence is completely compliant with the GDPR, and we get a proof of correctness. The proof itself is not that readable, but it can be made readable. It's a connection proof generated by the Torah improver we use mlinkup. There are different other questions, but I think we can skip them for now. Okay, this was a quick example of how the tool can check compliance automatically. Clearly, okay, so as a conclusion, we've seen a tool which can get a formalization of problems and can check them against the privacy legislation, like Article 13 of the GDPR, and it can give a proof of compliance or in general a counter model of non-compliance. Right now, not all the features that I mentioned are implemented. First of all, we don't cover all relevant privacy law. We cover only a few articles of the GDPR, like Article 13. And our current focus is to extend it to the whole legislation. We also don't produce counter models. It requires the plug-in of another kind of Torah improver, like Nitpick, and it is a current work. And lastly, and most importantly, right now the user has to formalize the problem, and this is not a trivial problem. So we hope to use a natural language processing to automate the formalization, and we also hope to deal with, so we are going to deal with easier problems like BPN diagrams, which are already semi-structured. If you want more information about the project website is iComply with AI at the end, .eu. and you can have more information there. Thank you very much.